of all, I'd like to thank Department of Physics, Namchi Government College, and Dr. C.P. Khatiwada sir. And my roll number is 19NS0082, and my topic is series and parallel LCR circuit. So first of all, let us talk about resonance. Resonance. It is when the period of applied frequency matches. Applied frequency matches when the period of width. This frequency matches with the natural frequency of a body, the amplitude of a vibration become maximum. Amplitude of a vibration becomes maximum. This phenomenon is called resonance. And next topic is forced vibration. Forced vibrations are the vibrations in which a body vibrates, with the frequency other than its neutral frequency. The neutral frequency which is under the influence of external force. The next is, what is the condition of resonance in an LCR circuit? Condition. When we can say that it is in resonance, circuit is in resonance. A circuit is said to be in resonance when the applied voltage and current are in phase. Now let us talk about the expression for resonance frequency. For a series LCR circuit, the inductive and capacitive are at equal resonance, and capacitive are at equal resonance. I will draw the diagram of LCR circuit in series. This linear goes first resistance and then capacitor in series LCR, and then here is and here goes current. So this is LCR in series diagram. LCR series, and now I will show you the expression. Expression for resonance frequency is XL is equals to XC, where omega is equals to 1 by root LC. Omega L is equals to 1 by omega C, and is equals to 1 by 2 pi under root LC. And our next topic is bandwidth. Bandwidth of series resonance circuit. Bandwidth of a series resonance circuit. So at resonance, the power of a series LCR circuit is LCR of a series LCR circuit is I square R. Current is equal to resonance is I square R. Now let us decrease or increase the frequency until the average power absorbed by the resistor in the series LCR becomes half of the maximum power absorbed at resonance. When power is absorbed at resonance, when power is absorbed at resonance, when the power is absorbed, we got two frequency points. Called half power point, which is called half power point. And the difference between half power point and the difference between these two half power points, difference between the two half power points is called bandwidth of a bandwidth. As we all know that series circuit is also called acceptor circuit. Series circuit is also called acceptor circuit. Why? Because the impedance of the circuit is at its minimum so easily accepts current whose frequency is equal to its resonance frequency is equal to its resonance frequency. So this is the reason that why series circuit is also called impedance acceptor circuit. The next is importance of series circuit. Importance of series circuit. Importance of series circuit. Series circuit. Circuit. So importance. So one importance is for high frequency AC, for high frequency alternating current, in radio communication, a series resonance circuit. A series resonance circuit is used. A series resonance circuit is used. Resonance circuit is used. Circuit is used. Next is LCR circuit. LCR series circuit. LCR series circuit are also used in frequency filter circuit, like frequency filter circuit, frequency filter circuit, like for example, like high pass filter, low pass filter, and low pass filter and band pass filter. So these are some examples of importance of series LCR circuit. Now let's learn about parallel resonance circuit. Parallel resonance circuit. First of all, let's draw the diagram. For a parallel resonance circuit, let's draw the diagram. First of all, we have to do line, and then line, and then draw use capacitor. Here is inductance. Here goes current, resistance, and here is a meter, like this, and this is in parallel. Here's V. Here goes IR flows, here IL, and here IC. This is capacitance, inductive, and R. And here is the current flowing current directions. So this is the diagram for parallel circuit. So a parallel circuit containing a resistance R, inductance L, and capacitance produce a parallel resonance into L, and a capacitance C will produce a parallel resonance, and this is the diagram of parallel LCR circuit. parallel LCR circuit. Now let's talk about the difference between series and parallel LCR circuit. Okay. At resonance, the series LCR, the series LCR circuit shows the maximum current passing through the circuit and in parallel LCR circuit is just opposite. In parallel LCR circuit is just opposite. The current passing through the current is minimum. The current passing through the circuit is minimum. Let us talk about quality factor of an LCR circuit. So what is quality? The sharpness of the peak is measured by quality factor. The quality factor relates the quality factor relates the maximum energy stored in the circuit, which is the reactance, and to the energy dissipated to the energy dissipated which is the resistance. During its cycle of oscillation. During its cycle of oscillation. In other words, in simple words, it is ratio of resonant frequency FR to the it is the ratio of resonant frequency to the bandwidth which means smaller the which means I think is the higher the circuit, the smaller bandwidth, which means higher the circuit, smaller bandwidth, and its expression is Q is equals to FR by BW, which means bandwidth, and Q is equals to 1 by R under root L by C. In earlier video, we talked about the difference between series and parallel circuit. That series circuit at resonance shows maximum current passing through the circuit, whereas it's vice versa in parallel LCR circuit. So what's the reason behind it? Is in series LCR circuit, its maximum because it's maximum resonance of the impedance is minimum, and in parallel LCR circuit it is maximum because it stores the circuit energy. It stores the circuit energy. It stores the circuit energy in the magnetic field. In the magnetic field of the inductor and the electric field of the capacitor. In the magnetic field of the inductor and electric field of the capacitor. The energy is this energy is transferred back and forth between the inductor and capacitor, which results in zero current, which results in zero current and zero energy being drawn from supply. So this is the reason why in parallel LCR circuit the current passing through the circuit is minimum. Earlier we all studied that series LCR circuit is also known as acceptor circuit. So parallel resonance circuit is also called as rejector circuit. Parallel resonance circuit is called a rejector circuit. Because at resonance the impedance of the circuit is at its maximum and it suppresses or reject the current whose frequency is is equal to its resonance, so this is the reason why parallel resonance circuit is also called a rejector circuit. Now let us talk about quality factor or Q factor of parallel resonance circuit. It's a reciprocal of the expression of the obtained series LCR series circuit. Therefore it is defined as the ratio of the circulating branch current to the supply current. The ratio of circulating branch current to the supply current. So its expression is Q is equals to R under root C by L, which is just a reciprocal of series LCR circuit current circuit.